Alright guys, so sorry I'm not here today, but I'm going to be going over the part of the notes that we are supposed to cover. So it's Avogadro's law and the ideal gas law. Here, if you look at the notes, it's a good idea to just pause the video at any time so that you could actually go through and copy. And then I'm going to go through the sample problems with you guys. So Avogadro basically looked at the relationship between volume and how many particles there are. And another way to state a number of particles right here is also how many moles you have. Okay, so you guys should probably remember Avogadro when we were doing mole calculations before. And his law stated that if you have equal volumes of gas at the same temperature and pressure, so the temperature and pressure are kept constant, and the volume is also the same, then you also know that you have the same number of particles. Basically, his law just means that the more particles you have, the more volume you have. The less particles you have, the less volume you have. So they go up and down together and they have that direct relationship. So V over N is equal to K, where N is equal to the number of moles right here. And over on the side, you want to go through and actually copy down his law, or his equation that you guys are going to be utilizing. It's volume 1 divided by the number of moles 1 is equal to volume 2 divided by the number of moles 2. And you could just set it up as a ratio, just like what you guys have covered with me before, with the other gas laws that we've looked at. Now, the new law for you guys that we're going to be looking at is something called the ideal gas law. Okay, and the ideal gas law was actually derived just from the basic gas laws that you guys have already been studying with me. So your Charles, Boyle's, Gay-Lussac's law, those laws were all combined. And essentially this law is this right here. PV is equal to nRT. The R is a constant that you guys do not have to memorize for the test, but we'll be plugging it in. So this R right here is going to be going into that R for that equation right there. P stands for pressure, V is volume, N is the number of moles, R is the R constant, and T is temperature. And I wanted you guys also to write down what standard temperature and pressure meant. It's oftentimes referred to as just STP. We saw that one homework problem, I think it was number 7 yesterday on the worksheet that mentioned STP. And STP is just a temperature of 273 Kelvin and then 1 atmosphere of pressure. Now, the thing that you guys want to watch out for when you use the ideal gas law is the units. Pressure always has to be in atmospheres. You guys could see that right there in the constant. The volume always has to be in liters. Okay, so you could see all the units are right in the constant. N is the number of moles, and then temperature always has to be in Kelvin. The one that you guys have to be very careful about is pressure. You guys know there's like lots of different kinds of units for pressure, so we have to use atmosphere for that whenever we're dealing with pressure for that. Let's see. Now our next part to this is you could take the exact same equation, the PV-nRT, and instead of using N, the number of moles, we could plug in something else. You guys remember the number of moles is always equal to how many grams you have divided by molar mass. This little curlicue fancy M thing, it stands for molar mass. So all we did was we replaced the N right here with a G over molar mass. Okay. Now, a third way this equation could be utilized is right here. We could use density. Now, density is always equal to mass divided by volume, or G over V. So density just replaces the G that we have in the equation right there with the V that we have right there. So if you take out the G and the V, you end up with D. It's still molar mass on the bottom, and look how there's no volume on this end for the density equation. So I usually tell my students, I remember these equations, I call this NERT, NRT. I call this equation GERT, GRT, and the third equation is called DIRT. So I call it the NERT, GERT, and DIRT equation. But remember for DIRT, there is no volume over on the very left-hand side. So you want to make sure you look at that. Now, let's try these two sample problems out together that we have in our notes. It says, calculate the molar mass of 2.45 grams of a gas at STP if it occupies 12.31 liters. This right here is grams. This right here is volume. Okay, and I also know that this is at STP, so STP, you guys remember, is standard temp and pressure, so the temperature is 273 Kelvin, the pressure is going to be 1 atm. Now ask yourself what equation you should be using here. You're picking between Nurtgert and dirt, but because I have grams, I know I'm going to go and use my GERT equation. So I need PV is equal to GRT divided by molar mass. And let's go ahead and take a look at what this looks like when we actually go through and plug it all in. I have 1 atm of pressure. I have 12.31 liters, 2.41 grams, that goes right there. The R constant, the 0.0821, comes from that number right there. We're going to plug that in for R. The T is my temperature, my 273, and my capital M right here is the molar mass, which is actually what we're going to be looking for by doing the math. Okay, now to solve for this, all you guys have to do is you're going to be cross-multiplying all this stuff. You're going to go 1 times 12.31 times M, so we get 12.31 L. I'm sorry, 12.31 M. And on the right side, you have 2.45 times 0.0821 times 273, and we get 54.912585. Now to solve for M, I'm going to take the 54.912585 divided by 12.31, and then you guys wind up with your final answer of 4.41 grams per mole. It's grams per mole because this is the unit that we always use for molar mass. It's G over moles. Now the second problem we have right here is a little different. It has 10 degrees Celsius, 102.5 kilopascals, and now this time we know density. Because this is density, we know that from the Nurtgert-dirt equations, we should be utilizing dirt. Okay, the pressure, check this out, is 102.5 kilopascals, but remember, we have to change pressure to atmosphere whenever you guys are utilizing any of these three equations. So one of the very first steps I did was using the conversions that you guys learned on the day 1 of notes. You know that 1 atm is equal to 101.325 kilopascals, and I divided to get it to 1.0116 atm right there. So I'm not going to be using this number, I'm going to be using that one. Another thing you guys probably want to change is it's 10 degrees Celsius, but you want Kelvin, so it's going to be 100 or 283 Kelvin is what I'm going to be using. And one more time, I'm solving for the molar mass of air. Okay, so this one I'll plug in with you guys. It's P is equal to dRT over molar mass. Let's plug in. My pressure is 1.0116 atm. The density is 1.26 grams per liters. The R constant is 0.0821 liters, atmospheres over moles K. And temperature is 283 Kelvin. Now we're going to be dividing this entire thing by my unknown molar mass, and we're going to go through and solve. So 1 times, or 1.0116 times molar mass, and then I'm going to multiply everything on top together, and then divide it by 1.000116. And when you guys do that, you get a molar mass of 28.9 grams per mole. And that's it. The homework that you guys have for tonight is in the book. It's page 167 in the book, numbers 33 to 38. I'm also putting a picture of this on Google Classroom. The pink is the answer, so you guys can use that to check your work. And I'll be checking everything off for you guys tomorrow at the beginning of class. All right? Thank you.